Okay, so welcome to Math 10. For the first part of today's uh, session, what we're going to do are these 1, 2, 3 warm-up questions that you see on the left here.
Okay.
All right, so you can start with that, and we'll correct them all together in about maybe 5 minutes if it takes you that long.
Yeah, 5 minutes.
Sure. You ready? On your
Yes.
marks, get set, go. Hmm. Okay, so the solutions now to the warm-up questions. Number one, let's see. One thing that you can do is recognize that 288 is the same as 144 times 2. What makes this special is that 144 is a square number. And so that means you can write it like this. 144 and then a 2. You can split up the square root. Well, what's the square root of 144? 12. Give them the final answer like that. If you didn't see that this is 144 is a square number inside of here, then there is another way. So reach out and let me know and I'll show you. Now, number two, looking at this goes to the exponent rules from yesterday. So the thing to recognize is that this 3 on the outside, it goes to each thing on the inside. So it's going to go to the 4. It's going to go on to the x squared, the y cubed, and also the z to the power of 4. So that's going to look like this. The 4 gets it. The x squared gets it. The y cubed gets it. And lastly, the z to the 4 gets that original 3 that's there. Working out each of these terms, 4 to the 3, that's 4 times 4 times 4, 64. In this situation, with a bracket in between, you'll multiply those together and you get x to the 6. Same here. Bracket in the middle, so these multiply together, you get y to the 9. And then lastly, same, z to the power of 12. And that takes care of that one. For the last one, number 3. You got to remember that when you're dividing, the exponents are subtracted from one another. So let's see how we can use that. We have 4 over 12. That for sure can reduce. Reduce is another way of saying simplify. The x's are nice. The y's will be a little strange. So 4 over 12. 4 goes into both. And that will leave a 1 over 3. For the x's, because we're dividing, we subtract. And so we got 7 minus 5, which will be a 2 on the top. And then on the bottom, this is where you can subtract, but it gets a little weird. 2 minus 3 is a minus 1. So you could look at it like this, or remember that this means there are 2 y's multiplied together. This means there are 3 y's multiplied together. So you could have it like 2 y's over 3 y's like that. So those will cancel out. Those will divide out. And then you're left with a y that's on the bottom. from what I've shown you so far, that's probably the way to do it. Okay, but then you get a good looking final answer. X squared on the top, 3 on the bottom, this single y that's left on the bottom. Finished up, just like that. So now what we're going to do is we're going to move on to the main part of today's session, which involves adding a few more exponent rules to our list that we have. All right, welcome. So this is going to be the main part of the lesson today, where we're adding some more exponent rules to our list. The ones we had from before, we had something like if terms are multiplied, the exponents get added. We just used that. If terms are divided, exponents subtract. We used that one. We used this bracketed one. So that's the 14. We just used this one. X12, Y6 with a 3, so that's X6, Y18. And now, as you can see on our list, on the board there on the left, we have x to the power of 0 is equal to 1. So that's new for us. And this means whenever we have anything to the power of 0, we get it equal to 1. So for example, 5 to the power of 0, 1. 8 to the power of 0, 1 as well. Okay, so anything to the power of 0 just gives a 1. This next fact here is that when you have a negative in the exponent, and if you move this base down to the bottom, the exponent, it stays the same. Stays as whatever is there. You could see that over on the left. It's an n to start with, so it's an n to finish with. The only difference is that it changes from a negative to a positive. The sign changes. So for example, if you add 5 to the negative 2, that's the same as having 5 to the plus 2 on the bottom. If you had, looking at the same rule, if you add 1 over 2 to the 3, that's the same as 2 to the negative 3 when you move it from the bottom up to the top. It also works like this. This would be a bit strange, but if you add 2 to the power of plus 4, if you move it downstairs, the exponent changes. Okay, it becomes negative 4 underneath. So that's a new and important addition to our exponent rules there. This example here on the screen is like a grown-up example from this negative exponents. Because if you take a look, what happens is the fraction on the inside, it just flips upside down. The fraction on the inside has x on the top, y on the bottom. And then, if you flip that fraction upside down, the exponent stays the same, but it's now no longer negative. It is positive. Could write positive, but usually we keep it invisible. Okay, so just to show you how it works, why does this happen? Well, remember, the exponent on the outside can go to each thing on the inside. That's one of our earlier rules. So this means you can have the top getting the exponent and the bottom getting the exponent. Okay, so looking at the top, we can move it down to the bottom over here. And when we do that, the exponent changes from a negative to a positive. So we get x to the plus n. From the top to the bottom, positive exponent now. Same thing's going to happen here. It goes from the bottom up to the top. So it stays like that, but the exponent is now positive. And then this might seem like a new rule, but it's actually just this one in reverse where the exponent is on each thing. So we can pull it out and leave the individual bits on the inside. And so that creates what it is you were given in the beginning. Flip the fraction upside down, the exponent's going to change the sign. So let's try some examples with this. Being very careful about where this exponent is and what it acts on.
Okay.
Yeah, so Shota, you're here, help me out. This exponent, it's on the x for sure, but is it on the 2 as well?
Yes, sorry.
I said the exponent here is on the x. Is it on the 2 as well?
Yes.
Surprise. Oh, okay. Maybe I'll tell you then for free. When the exponent is written like this, it is on the x only. This 2 doesn't have an exponent on it. It's just the invisible 1. So watch. What we can do to write this with a positive exponent, it's going to be 2 times, we can put this upside down. X goes on the bottom, plus 3 now. And on the 1 on the top, just to keep it there. Okay, so the minus 3 is on the x only. X goes downstairs. So the 3 changes to positive, and it looks like this. As a reminder about multiplying by fractions, it's the top times the top, and then the bottom times the bottom. If there's no bottom, then there's an invisible 1 down there. So for the top, we have 2 times 1, that's just 2. And for the bottom, we got invisible 1 times x cubed, 1 times x cubed, x to the power of 3 is just that. Now, this question is a little different than the one that's on the right, because the one on the right has the brackets on it now. And so that means the 2 is together with the x. So the first step is to put the 2x onto the bottom, all together, right? Still all together like that. But the exponent will have a sign now of positive. It will be plus 3, looking like that, leaving a 1 on the top. What happens next is we use that rule where this exponent goes to each thing on the inside. It's on the bottom, but the rule still works. 3 goes to each thing on the inside. So that means the 2 gets the 3, and the x gets the 3 as well. The last step would be to work this out. And so you get 1 over 8 x cubed, like that. 1 over 8 x to the power of 3. And Shota, any questions from that?
Yes.
Okay, go ahead.
Yeah, I have a question, but I don't know how can I ask you.
Do your best. Is it about
Okay.
yeah, go ahead.
So the first step, this the one.
Yeah.
Yeah, I don't get this.
Don't get why this is?
Yes.
All right. So this is the question that we have here.
Yes.
You agree that it's 2 times x to the negative 3?
Negative 3. Yeah.
2 times x to the negative 3?
Oh, okay, I got it.
Yeah?
Yes.
Okay, perfect. All it took was a little dot, eh? Magic. Yeah, magic.
Well, that's a little bit hard.
Okay. How about this side then? Is that all okay?
Yes.
That side's good?
Yes.
Okay. Then we will go on to the next question. Next example. Ooh. Let's try that one.
Okay.
So notice, if it's negative, you got to make it positive. If it's positive, you just leave it. It stays where it is. So the 5, are we going to move the 5 around at all? No.
No.
The 5 is up, there's no exponent there, right? So the 5 stays, and it'll stay on the top. And so watch. We thought about the 5, we've taken care of it, so we put a little check mark there. How about this, x negative 2?
Bottom
That's right.
is the bottom.
Goes to the bottom, right. And by the way, I say bottom a lot, just because it's like English. But the math word for the bottom that you might see is denominator. The top is numerator.
I cannot see it.
It's on the I got it on the camera screen. So it should show up in the video if you take a look at it. Okay, or actually I could type it over. I think I could type it over here. Let's take a look. Put one of those, one of those. Oh, look at that. Bottom. All right, the math word for the bottom is denominator. The top,
Denominator.
yeah, numerator.
Numerator.
Yeah. Myself, I use them both, usually bottom and top. But hey, this is math class. We got to be professional. Got to use proper vocabulary sometimes. All right, so going back to the question, you said x to the minus 2 goes to the bottom, and I agree. That's correct. It goes to the bottom, and it's no longer negative. The negative is gone. So it stays positive like that. It's good. This is y to the plus 3. That stays in the numerator. And then the z minus 4, that goes to the denominator, goes to the bottom. So it'll be z, it'll be 4, but it'll be plus, because it's switched from the top to the bottom. Finished. Any questions from that one?
Nothing, I got it.
Perfect. The next one, I hope is harder. I wanted you guys to be challenged. Oh yeah, this is starting to be good. Okay, so there's actually 2 ways to do this one. So one way, and I'll write it on the, or type it onto the screen here, and then I'll show the work over here. So there are 2 ways to do this one. The first way is to flip the inside first with our new rule, and then simplify like usual. Or, without the 2 there, or you can just apply the exponent, apply the outside, I mean, and then flip each part afterwards. So you can flip the inside first and then simplify, or apply the outside and then flip what you get. Okay, so I'll show both ways. The first way is to flip the inside first. So we have x2, y3 like this, x to the power of 2 officially, y to the power of 3. Now it's a negative up here to start with, a negative 4. But when we flip it upside down, that is when we flip the inside upside down, it becomes a plus 4 now. That's our new rule from earlier today. Okay, and then it says simplify after that. So that means the exponent on the outside goes to each thing on the inside. So that means the top gets the exponent of 4, and then the bottom gets the exponent of 4 as well. I think in earlier questions we had terms multiplied together. So it looked a little different, but you see the 4 on the outside goes to both on the inside. This is just with dividing. It still works. 4 goes to each thing. Okay, and then you can finish it up. Because in this situation, the exponents are multiplied, exponents are multiplied. So we get y to the 12 and over x to the power of 8. Finished like that. Okay, so that's flipping first. Bottom goes to the top, top to the bottom. The exponent changes sign. Then it just goes to each thing inside the brackets. So this other method is to apply the outside first. And so this is the question to start with. It's a -4. And then instead of flipping it, each thing gets the -4. All right, so on the top, we still multiply even though it's a negative. You get x minus 8 over y minus 12. And see, when you move the x now to the bottom, it'll change to plus. When the x goes to the bottom, the exponent changes to positive. And when the y moves to the top, the exponent will change to positive like that. And as you can see, it gets the same final answer. So I point out there are two different ways because sometimes one way might be nicer than the other. And yeah, you choose the one that will work best for you.